Well, the time is exactly 1 o'clock. So in the interest of time, we will go ahead and get started. And if other folks join in, then that's great. So thank you so much for joining us this afternoon. Really appreciate it. We are so excited to be exploring 3 data-driven actions that enhance mathematics instruction with you this afternoon, and really appreciate you giving us a little bit of your time. We recognize that every day is a very busy day, but it is incredibly busy, especially this time of year. So very much appreciate you electing to spend some of your time with us this afternoon. My name is Sarah Wood. I'm the Technology Development Manager for National Training Network, and will be co-facilitating with my partner here, Heather Thomas, as we explore this concept further.
And my name is Heather Thomas. I am the data specialist with National Training Network, and I'm also a coach. And I'm very excited to be spending some time with you this afternoon.
So before we get into the 3 data actions a little bit further, we're going to just start with a really quick quiz. Isn't that exactly the way you want to hear a session start off? But let's just go ahead and take a moment. So I'm going to let you read the question that's here on the screen. And just kind of to yourself or in the chat, if you would like to, just kind of think about what you think the answer should be for the number of the covered spot in the parking lot. Okay. And in the interest of time, I will just go ahead and reveal here. This is a real assessment item that has been implemented and given to students. And if you look at it and the image at the bottom of the screen here, the correct answer is actually 87. And all that somebody would need to do is just flip that picture upside down in order to be able to determine that. So that is question number 1. This is a 2-question quiz. So you only have 1 more question, and I'll go ahead and show question number 2. So this will be 1 line. Okay, and on this question, the correct answer is actually this little tiny diagonal red line here that changes the plus symbol or the addition symbol into a 4, making that number down here at the bottom here 545. So although students would have to apply some basic algorithms or addition properties in order to get that to be true, this is really, again, kind of more of like a riddle and not necessarily assessing anything that is standards aligned. So just kind of reflecting on the 2 sample items, let's think about this. Why do we use mathematics assessments? Is it question number 1? Or answer number 1, excuse me? You would think I've never seen Family Feud before in my life. Answer number 2 on the board. Number 3, number 4, 5, or 6. So looking at the previous 2 examples that we had at the beginning slides here, yeah, it could just confuse students, or it could just be for fun. But as I had just previously mentioned, we're not really necessarily, although they look like they're math items because I have numbers included, aren't necessarily testing anything that's completely standards aligned or standards based, where students would actually need to apply some mathematical knowledge in order to be able to complete those questions. So the purpose here is, and the purpose of our session is really to kind of take a look at why are we using mathematics assessments, and then how can we use them more effectively to help drive teaching and learning moving forward. And it's not to confuse students or for fun or to have little tricks or riddles or games.
So when we think about the idea of assessment literacy, the U.S. Department of Education defines that as knowledge, skills, and process associated with designing, selecting, implementing, scoring, and using high-quality assessments to improve student learning. And the most important piece there is the idea of improving student learning. As we think about some data-driven actions that we can do surrounding assessments, we have to keep in mind that we want to be intentional about effectively designing assessments to maximize the quality of data we get so that we can have a positive impact on student learning. And as we think about 3 questions we could ask, you can go to the next slide, Sarah, as we're focusing in on this idea of assessment literacy, we always want to think about what is being assessed, what kind of data we want to collect from these assessments, and how the data will be used to inform instruction. One of the first data-driven action steps that we can do is really focusing in on maximizing the collaboration. When we think about PLCs and being able to maximize the effectiveness of that, we really want to engage in this perpetual cycle of inquiries. So we want to ask several questions as we're working through the collaboration process. The first 2 I'm going to address, and we're going to address the other 2 a little bit later. But the first question we want to think about is, what do we expect students to learn, and how do we know if they have learned it? When we think about what we expect students to learn, we really want to focus in on the standard. So I have a sample standard on the next slide here. And on this slide, we're looking at 6 RP3. We're going to use ratios and rate reasoning to solve real-world and mathematical problems by reasoning about tables of equivalent ratios, tape diagrams, double number line diagrams, and equations. So as we look at this particular standard, there's 2 things we need to think about. The first thing we think about is, what is it that we want students to be able to do? And in this particular standard, we really want them to use the ratio and rate reasoning to solve real-world and mathematical problems. So as we're assessing, that's where we want to kind of hang our hats and make sure that our assessment questions are aligned to that. The other piece of this standard is the avenues in which students can approach what they're supposed to do. So this particular standard lists tables, tape diagrams, double number line diagrams, and equations as ways in which students could be able to use the expectation of what they're supposed to do. So we have a couple of assessment questions we want to take a look at now that we sort of understand what this standard is asking of us. In this particular assessment piece here, this is really sort of the lesson, but you can see where it really just outlines for students exactly how to create the tape diagram. It models it for them. There are several example problems with that particular tape diagram model. And again, that tape diagram is a strategy that can be used to attain and achieve in the standard. A lot of times what we see with items that are created from things like this is a replicated item. So if you look at this question here about Ollie and his 2 games that he wins for every 5 that Noel wins, it is essentially the exact same question and problem that he previously worked on, just with different names and different values. And so this limits student data, because essentially what this is going to tell us is whether a student can replicate the actions that we previously did, but it doesn't give us a lot of information on whether they can apply these concepts in different scenarios and different contexts. And with the standard saying they need to solve real-world problems, this tells us about whether they can replicate and not necessarily apply to other situations. Another thing that we often see when we are looking at questions for assessments is sometimes an assessment question will push students into one specific strategy. So here's another question that addresses 6 RP3 with a real-world situation. And what we see here is that they're asked to complete the double number line to show how much red paint would be needed. Again, this is a strategy and not necessarily the standard. The double number line is an avenue to show mastery of the standard, but they also could use a tape diagram, a table, equivalent expressions and equations. So students have multiple ways that they could access this particular standard. This question is not necessarily a bad question, but maybe a better option would be to take the double number line out and focus really on the content and the standard itself in this real world application problem here. So you can see the difference is the first one pushes them to use a specific strategy. The second one asks the exact same question of them, but they now have the flexibility and autonomy to choose their own strategy. So as you're working through planning in PLCs and you're analyzing these assessments, there's a few things that we want to keep in mind. The first thing we want to do, you can switch to the next slide, Sarah, is ensure that students have the opportunity to apply new knowledge learned. So making sure that when we're choosing assessment questions, we're not choosing questions that look exactly like the way we taught it. We want to think about how we assess first, and then think about how we teach students to access the standards. And we also want to make sure that questions are standards-based and not strategy-based. So one way that we really want to capitalize on the time of collaboration is to focus in on the types of questions that are being asked with our assessments. In the next slide, we're going to show you two different questions. And I just want you to think about which one of these questions you feel like would be the better assessment question. And there's a poll at the bottom. If you would like to answer the poll, you can choose A or B, whichever question you feel like is the better assessment question. And this is going to lead us into our second data-driven action that we can use to help improve instruction. So when we think about this particular question, you can move to the next slide. We really want to focus in on distractors. And distractors, as you're going to see on the next slide here, is an incorrect option for selected responses items on an assessment. And these can be very beneficial in generating data for us as if we've designed good distractors. So when we think about a good distractor, there's two things specifically in math that we want to focus in on. The first thing we think about is plausibility. And what this means is when I put an answer choice on an assessment item, or when I look at an assessment item that already has answer choices, do the incorrect answers appeal to students? Do they attract their attention? In order to get them to do this, it really needs to be a common error that they may make in computation, or if it's more of a word problem centered assessment item, we want to think about how students may misinterpret information in the word problem. And when we play into these common errors and the misinterpretation of word problems, it really increases the diagnostic value and gives us a much higher quality of data that can help us inform instruction. So on the next slide, we have an example of what this looks like with question A. So if you look here, question A asked about the value of 2 3/8 and 2/3. And answer choice A, the distractor, is that they did not regroup the improper fraction correctly in the sum. So this gives us a very concrete example of the error that a student is making a little bit easier to address later on. In B, again, they added the numerators and denominators straight across. So another very common misconception that is seen in this particular cluster of standards. And then in C, they subtracted instead of adding. And so in this particular problem, this may be a misconception that students have. On the flip side of that, when we look at question B, if you notice question B, all of the answer choices here have 40 as a common denominator. And what this does is it limits the type of data we get in terms of understanding why students are choosing the incorrect answers. By giving them 40 as a common denominator, it gives them a clue as to how they may go about solving it. And even if they aren't able to solve the problem, we don't really know whether it was a random guess or if there's a specific type of error students are making, because there's no intentionality behind the distractors and the misconceptions that we're putting in front of students. And so when we think about this, I want to cycle back to this idea of PLCs. These are conversations that we need to be having in the PLCs. The last two pieces from the PLC, the last two questions, Sarah is going to talk about in terms of once we get this data, what is it that we need to do with it as we start analyzing a little bit. So we've talked about what we do we expect students to learn, how we know they have learned it. And Sarah is going to talk about the last two questions and what we do with the data once we get it.
So for this last piece of information, how will we respond when some students do not learn, and how will we extend and enrich learning for students who have demonstrated proficiency? So let's just go ahead and take a look at an example here. So we are using a tool that we have at National Training Network called Mathematics just to help illustrate our point, but please feel free to use and evaluate whatever resources you have access to within your own respective role. But what we're looking at here is actually a data report for an assessment that was created and administered to students, and it aligns to the previous standard that Heather was expanding on with some of that PLC work, which is the standard 6RP3. And so at the top of the screen, I can look at it really quickly and superficially, and I can see that, okay, my students appear to be struggling more with the mastery of 6RP3A in comparison to 3B and 3D. But that is a very high level in terms of evaluation, the same as if we were to just look at the basic scores in the table below. So if I was just looking at overall percentage or score rate, I could just kind of say, okay, these kids have it versus these kids don't. But just kind of piggybacking off of what Heather just said about taking a look at distractors, we can dive into this information further to really give us some insight into where those levels of misconception are, where we need to continue to develop student understanding, and where we have those levels of mastery and how we can enrich moving forward. So this is a completely multiple choice test. So it really only addresses certain assessment items. But if you look here, there are 6 questions. You see the standards that they align to, as well as the correct answers. Anything that's represented with green letters in the table below are correct responses, versus the red letters are those incorrect distractors that students may have chosen. And so what we're really going to do now is take a deeper dive into those incorrect distractors that students may have chosen and how that can inform our instruction moving forward. So for example, if I were to take a look at this table specifically, I see that I have 3 students, Angel, Bert, and Jeremiah, who for questions 2 and 3 all chose the same common distractors. They all chose answer choice B for number 2 and answer choice C for number 3. So let's dive into that a little bit further. And so for question number 2, this is question number 2 from the assessment, and all of the students had selected answer choice B. And if you look below each of those answer choices, you'll see our resource kind of generates a reason for answer, which gives you a little bit of insight and information about what that misconception is that students may have fallen into in order to select that distractor. So the students may have chosen answer choice B because they were looking for a pattern. They were looking for a difference between these 2 columns within the table. So 5 minus 1 is 4, 6 minus 2 is 4, 8 minus 4 is 4. And then subsequently, if we were to look at question number 3, all of the students chose distractor answer choice C. And again, with that particular question, they're looking for that common pattern, that difference between the scones and the croissants. So 7 minus 2 is 5, 14 minus 9 is 5, 21 minus 16 is 5. So what is this information telling us here? So this is telling us that those 3 students are looking for patterns of a constant difference of the values for the ratio that are represented within the table. And they may not have a solid understanding of what those ratios are really representing. So as I'm looking to group students or to continue to work on developing understanding, I'm not just going to reteach how to represent ratios and rates within a table. Instead, I'm really going to hone in on the fact of what that information in the table is telling me versus looking for that constant difference or those patterns within the questions that are presented to me. And then going back to or referring to this same set of data points again and taking a look at what's available to us there. Let's take a look at another example. So I'm going to take a look at questions 1 and 2. So we're overlapping that question 2, which we just kind of evaluated for some of the students. But when I look at that, I have 2 students, Keith and Spencer, who chose different distractors for those 2 questions. Again, they're common among the 2 students, that both of them are choosing C. So it sets apart from the other students who chose a different distractor for number 2. But then what is that giving? What is that information gleaning for me? So for number 1, both of those students chose answer choice C. And it's telling me that they mixed up or they inverted the way that it was expressed versus what the ratio is asking for in the question. So instead of giving it in one way, they gave it in the other. And if I look at question 2, which is the same question that we looked at previously, but we're just looking at a different distractor here, we can see again that those students selected an answer choice where it reversed the ratios. So what is this information telling us? It's not just telling us that the kids got it wrong or that they don't get ratios, but what don't they understand about ratios? And it may be that both of these students are not recognizing that there's a significance in the order of which the values are represented within a ratio itself. So again, I may be, rather than just trying to reteach question 2 to all 5 of those students who had that question incorrect, I may actually have 2 separate things that I'm addressing based on the way the students are responding and what that information and that data is telling me. So if we were to summarize some of the items and some of the takeaways from the 3 action items here, the first thing is to engage in PLC work. So as you're working and you're collaborating with colleagues at a grade alike level, you want to take a look at evaluating the types of assessment items that you are giving to students before you give them and before you're implementing those assessments. And with these things in mind, is it standards aligned? So we know that there's a lot of different resources that are available to you out there when it comes to using different assessment items, but some of those things are aligned more heavily to a resource. So it's testing the way the resource taught it versus what is the standard actually requiring that the students need to be able to master and know. And then does it avoid replicated practice? And I think a lot of us have been guilty of this as educators, is that you take a look at something, you scaffold it for students, and then you give them that exact same thing to replicate and to practice and to implement. And so we're just changing names, we're just changing numbers. So you're almost kind of inflating what the student scores could look like there, because you're really not testing to necessarily know. They may just be memorizing things and then regurgitating them to you. And then if it is a multiple choice item, what do those distractors look like? Are they like that question B that Heather had referred to earlier on, where all of the answer choices already had the correct common denominator available? So it's inferring that students even know that they need to find a common denominator, or are all of those distractors plausible things that students could be doing in terms of like performing a incorrect operation or some sort of other common misconception that is giving us additional insight into maybe what their misunderstandings are or their understandings. So all items to take into consideration as you engage in that PLC work and collaborate, and really kind of evaluate the resources and the assessments that you're putting in front of students and how they're really kind of help driving the knowledge of what students' understanding is to help drive instruction moving forward. So just kind of piggybacking off of what I previously said, if it is a multiple choice item, evaluating those distractors, are they plausible? And then what does that say about the student understanding and the misconceptions? So I kind of already touched on that. That's just an additional summary. And then for that number 3 is really exploring that data. So as you're grouping students, it's not, okay, these students got this question correct, or this student got this question incorrect, or this is, the percentage level that they're falling into, but really looking at and diving into, are there common distractors that students are selecting across that board? What does that tell us about the misconceptions or the student understanding to really help hone in on how we can continue to develop understanding moving forward? So those are really just the 3 action item takeaways from evaluating the types of data and what it really tells you about instructional decisions moving past that. So we actually are getting ready to wrap up just a few minutes early, which is awesome. So hopefully we can give you a few minutes back in your afternoon. But just to kind of summarize, I'm Sarah, this is Heather. We are so appreciative of you giving us a little bit of your time, especially at such a busy time of year. I will say, as I am a participant going into a session or when I'm presenting at a session, like my goal really is to have one takeaway, one actionable item that you can take and turn and try to implement and think big, start small, scale fast. So hopefully there's something small that you could take away from this session that you can implement within your respective role moving forward. Should you have any additional questions, or if there's anything you want to explore further, our contact information is on the screen, so please feel free to reach out to either one of us. Or also, if you would like to explore any of our additional solutions, or if you have any other questions, you can always access us via our website, which is www.ntnmath.com. And if you just go to our drop down for About NTN and go to our team, you'll be able to find our icons there, and you can just reach out to us directly from that. So if you have any questions or comments, we will stay online for just a few more minutes. Otherwise, thank you again so much for spending a little bit of time with us, and we hope you have a great rest of your day.